This is fluid mechanics and hydraulic machinery lab, which is common to civil engineering, mechanical and electrical and electronics engineering branches. ఈ ల్యాబ్లో ఫ్లో పైప్లో ఎంత వెళ్తుంది, కాలువలో ఎంత వదలాలి, తర్వాత ట్యాంక్స్లోంచి ఎంత వదులుతామో ఎంత వదలాలి ఇవన్నీ కనుక్కుంటాం. ఈ ల్యాబ్స్ అన్నీ ఇది ఒక కాలువకు సంబంధించిన ఎక్స్పెరిమెంట్. ఇందులో ఎంత రిలీజ్ చేయాలి క్రాప్స్కి ఎస్టిమేట్ చేస్తాము. అలాగే పైప్స్లో ఎలా కనుక్కోవాలి అన్ని ఎక్స్పెరిమెంట్స్ ఉన్నాయి. దీనికి తోడు ఇందులో టర్బైన్స్ అండ్ పంప్స్ ఎలా వాడతాము, వాటి ఎఫిషియన్సీ ఎలా ఉంటుంది, ఎక్కడెక్కడ ఏ టర్బైను ఏ పంపులు వాడాలి తెలుసుకుంటాం ఈ ల్యాబ్లో.
I am Professor Ramarao from Mechanical Engineering Department. మనము ఇప్పుడు 4th year ఫస్ట్ సెమిస్టర్లో ఒక ల్యాబ్లో ఉన్నాం. ఈ ల్యాబ్ పేరు ఇన్స్ట్రుమెంటేషన్ ల్యాబ్. మేము ఇక్కడ చేసేది ఏంటంటే రిలేషన్షిప్ బిట్వీన్ ఇన్పుట్ అండ్ అవుట్పుట్, దానికి సరళ రేఖ అంటే లీనియారిటీ వీఆర్ గోయింగ్ టు టెస్ట్ ది డిపెండెన్సీస్ బిట్వీన్ ది ఇన్పుట్ అండ్ అవుట్పుట్ ఆన్ లీనియారిటీ. 11 ఎక్విప్మెంట్స్ ఉన్నాయి. ఈ 11 ఎక్విప్మెంట్స్ మీద 11 ఎక్స్పెరిమెంట్స్ చేస్తాము. ఉదాహరణకు యాంగులార్ డిస్ప్లేస్మెంట్ by using the variable capacitor, strain measurement instrument for finding out the strain in any elastic material. Strainer అంటే ఏంటి, by using various methods మనము ఒక యొక్క స్పీడ్ మనం పట్టుకుంటాం and we are going to measure the speed by using different methods and we are cross check it how far the accuracy is there. CAD CAM 4th year ఫస్ట్ సెమిస్టర్లో వచ్చే CAD CAM ల్యాబ్లో CAM సెక్షన్లో ఉండండి. Here we are going to use sophisticated అంటే స్టేట్ ఆఫ్ ది ఆర్ట్ టెక్నాలజీ ఉపయోగించే మెషిన్స్ని మనం ప్రోటోటైప్ చూసి పిల్లలకి ఎక్స్పోజర్ అన్నమాట అండి. అంటే ఏంటి, యాజ్ వీ హ్యావ్ టు మూవ్ అలాంగ్ విత్ ద టైమ్. దిస్ ఈస్ కాల్డ్ కంప్యూటర్ ఎయిడెడ్ మ్యానుఫ్యాక్చరింగ్ అండ్ దిస్ ఈజ్ ఎ CNC milling machine. Here this is we are going to do milling operation. This is CNC turning machine సార్. ఇక్కడ మనము వేరియస్ ఆపరేషన్స్ అన్న ఈ CNC టర్నింగ్ మెషిన్ ఉపయోగించి చేస్తాం.
Good evening, I am Rajita. I am Assistant Professor of Mechanical Department. So this lab concerned about strength of materials lab. Okay, so this is a spring test machine where we can see the tensile spring coil and tensile testing machine. So this is a simply supported beam.
So myself is Suresh Gudupudi, Assistant Professor in Department of Mechanical Engineering. Here my lab name is Machine Tools Lab. Here we have the different kinds of machine tools. So this is machine tool called lathe. Here we can reduce the diameter of the cylindrical shafts by providing the longitudinal feed to the cutting tool, and as well as by giving the transverse feed we can reduce the length of the machine shafts, and we can also provide different profiles like knurling and step turning with help of other machine tools. And we can also have different kinds of machine tools which can put here. We can make the knurling operation on this machine tool, same lathe, and here also we can do the step turning process. And here we have a shaping machine to produce the flat surface by giving the reciprocating motion of the cutting tool and by giving the lateral feed for the workpiece. And here we have the slotting machine, vertical slotting machine used to cut the grooves and slots in the shafts and pulleys. It is the milling machine used for reduce the depth of the workpieces to produce the flat surfaces to make the holes in any material parts. Okay. This is the surface grinder which is used to remove the material with fine layers. This is the tool and cutter grinder used for grinding the cutting tool angles.
I am D. Sudhakar Reddy. I am assistant professor in mechanical department. This is the production technology lab. Production technology lab itself tells us the different technologies used in production. Okay, this is blow molding. Okay, in this we transfer or we inject molten metal into the mold cavity. After some time it solidifies and we take it out. In this we make water bottles, water caps. Mainly we use to produce blow or hollow pots. We use it to make parts like thin plates like dice. Yeah, this is arc welding used to join the metal sheets or metal plates. And there we use the non-consumable electrodes. This is spot welding. We use it to join metals by pressurizing and electrical resistance. And this is TIG welding. Here we use consumable, non-consumable electrodes. This is punching and blanking operation. Here we use it to make washers. Yes, this is the bending equipment. Here we use it to calculate the bending and bending stresses.
I am C.V. Gopal Krishna, Assistant Professor in Department of Mechanical Engineering. This engineering workshop అనేది basic mechanical sciences అన్ని బ్రాంచ్ల స్టూడెంట్స్ ఇక్కడికి వస్తారు. ఇంజనీరింగ్లో ఉన్న బేసిక్స్ పద్ధతులన్నీ కూడా ఇక్కడ నేర్పిస్తాం. ఇక్కడ నెంబర్ ఆఫ్ డిఫరెంట్ ట్రేడ్స్ ఉన్నాయి. టిన్ స్మితీలో ఈ చిన్న ట్రే నుంచి మొదలుకొని ఏరోప్లేన్, షిప్ బిల్డింగ్ వరకు కూడా షీట్ మెటల్ని బెండ్ చేస్తూ వివిధ రకాలైనటువంటి పనిముట్లు వాడుతూ పిల్లలకి నేర్పిస్తాం. దీన్ని టిన్ స్మితి అంటారు. కార్పెంటర్లు వాడుతున్న రకరకాలైన టూల్స్ వాడుతూ ఎలా ఏ పనిముట్లు దేనికి ఉపయోగపడతాయో పిల్లలకి ఇక్కడ నేర్పిస్తాం.
I am S. Srinivasarao, Associate Professor, Department of Mechanical Engineering. The name of the lab is Thermal Engineering, is also known as the Heat Engines Lab. So, in this lab, the purpose of the lab is to conduct various experiments on diesel engines, petrol engines, 2-stroke, 4-stroke, multi-cylinder engines. So, here we are going to perform the performance test on brake thermal efficiency, all these efficiencies of the engines. Now, this equipment is 4-stroke diesel cut model of 4-stroke diesel engine. We are going to verify the valve timing diagram of the engine. Cochrane boiler, Bob Cockle Wilcox boiler. Port timing diagram. This one is performance test on air compressors, air compressor and dismantle of engine. Force test on 4-stroke 4-cylinder petrol engine. This is a variable compression diesel engine, single cylinder diesel engine, 2-stroke petrol engine.
This is the Bhaskar Associate Professor in the Department of Mechanical Engineering. So, this is the heat transfer lab used in 3rd year 2nd semester. So, in this case, how to heat transfer take place in 3 modes, that is the conduction, convection as well as radiation. So, we have different types of equipment. In this equipment, we have to calculate the heat transfer coefficient by means of density difference, So, in this case, we have to calculate the heat transfer coefficient by using forced convection, that is by means of blow airs, This is also convection mode of heat transfer by means of pin-fin effect. That means the surface area is increases. This type of increasing area is used in 2-stroke petrol engine. So, here we have to calculate thermal conductivity of insulating powder. The insulating powder is the chalk powder by means of Fourier equation, under spherical equipment. So, this is the lagged pipe operators. In this case, we have to calculate the heat transfer rate in different zones. This is the base zone, this is the zone 1, this is the zone 2, this is the zone 3. So, this is the emissivity operators. Here we have to calculate the emissivity by means of a radiation mode of heat transfer. So, here we have to calculate the emissivity of gray body. So, this is the counter flow and parallel flow heat exchanger. In this case, both the fluids travel same direction, it is called parallel flow. If both the fluids travels in opposite direction, it is called counter flow heat exchanger. So, in this case, we have to calculate the effectiveness and efficiency of the heat exchanger. So, here we have to calculate the thermal conductivity of metal rod. The metal rod is the copper. So, how to calculate the thermal conductivity by means of conduction mode of heat transfer, right? Boltzmann operators. In this case, we have to calculate Stephen Boltzmann constant. It is compared to theoretical value. by means of radiation mode of heat transfer. So this is the unsteady state of heat transfer. In this case, we have to calculate heat transfer rate by means of unsteady. That means the heat transfer rate will change with respect to time. It is the thermal conductivity of composite valve. Here we have to calculate thermal conductivity of composite valve by means of different materials. This is the critical heat flux operator. In this case, we have to calculate the heat transfer coefficient by means of pool boiling curve.
Myself, C. Venkatesh, Assistant Professor in Mechanical Department. We are here to see your metallurgy lab, and the main purpose of this lab is to just see the internal structure and mechanical properties of a material. So here we can see this, some of this equipment. The main first one is cutoff machine, and thereof we can see your microscopes. We have totally 7 microscopes.
I am Bhavani. I am here to introduce you to metrology lab. In this lab, we will be introduced into standards of measurements. You might be wondering how we have to measure various parameters what we have learned till now. You will be introduced all those things here. For example, these are the laboratory standards, and we will be using all those vernier calipers, micrometers, geometrical parameters of tools, etc. In this one of the gear, you can measure teeth depth of the gear can be measured.